All right, this example is out of the chapter review on page 396. It's number 3. A popular blog reports that 60% of college students log into Facebook on a daily basis. The dean of students at a certain university thinks that the proportion may be different at her university. Right? Keyword different. She's not assuming high or low. She polls a simple random sample of 200 students, and 134 of them report that they log into Facebook daily. Can you conclude that the proportion who log into Facebook differs from 0.6? All right. So first off, our null and alternative hypotheses. Right. Our null and alternative hypotheses. Right. Since we are looking for a proportion, right, the percent, our null hypothesis is that the population proportion for this school is going to be a 0.6. Since she's not assuming higher or lower, the alternative hypothesis is that it is not 0.6. This is going to be a two-tailed test. Right? This actually makes it more difficult to reject the null hypothesis in general. Right? So what kind of a test do we do? Right? If we follow the flow chart, we're doing a proportion. So we do a one prop z-test in terms of our calculator. So we'd go to stats, tests, since we're doing the proportions. This is going to be a one prop z-test for us. Right, our P0 is our null hypothesis. Right, our P0 is going to be that it is the same at this school than it is in the general population, so 0.6. We had 134 out of the 200 people said that they logged into Facebook regularly, and since it's a two-tailed test, we're just going to do the not equals P0. That's the one we want. Looking at the numbers, right, I wrote this down wrong. 134 yeses out of the 200. 34 out of the 200 yeses. All right, so the test statistic right, that's my z. In this case is 2.021 to 3 decimal places. Right? The thing that I care about in terms of my hypothesis test is the p-value, p of 0.0433, right, to 4 decimal places. Okay? So my test statistic is 2.02, but the p-value is the thing that I am going to be used to calculate whether I accept or reject based upon my level of significance. Right, so assuming a level of significance of 0.05, right, do we fail to reject the null hypothesis, or do we reject the null hypothesis? Okay, so my alpha is 0.05, my p-value is 0.0433, and my p-value is less than my alpha. If the p-value is less than alpha, we reject the null hypothesis, right? So we have rejected the null hypothesis. So this study is statistically significant, and the conclusion comes down to that there is sufficient evidence to conclude that students at this university log into Facebook at a different rate than the 60% of the rest of the population. We can't really say in this study, based upon how we've set this up, whether or not it's more or less. It's higher than 60%. So 67% of the sample did. So if I was going to make a guess, I would test higher, right? Essentially, I would rerun this test at p of greater than 60, right? My z-value would be different, my p-value would be different. Right? And then I would have to do this again, okay? I would really have to do this again on a completely different sample, okay? But this is the only conclusion that we can draw, right? We have sufficient evidence that this school is different.